A runner checks their phone mid-stride. In one tap, the app maps the route, checks humidity, cues a high BPM playlist, and drafts a post. It feels like one cohesive piece of software. But the developer who built this app didn't launch a GPS satellite. They don't hold the licensing rights to a single song, and they certainly didn't code a global social network. Yet somehow, the servers of 4 distinct multi-billion-dollar corporations are talking to each other in real time, executing complex commands in a fraction of a second, all inside a 6-inch pane of glass. This happens through a web mashup. Instead of coding every feature from scratch, developers stitch together existing services from across the internet to create a unified experience. This composite approach has redefined development, shifting the work from creating isolated programs to managing a continuous flow of integrated data. Take the fitness app Healthy Lemur. It logs your weekly workouts, pings your location, and shares progress with friends. Tear the interface apart to trace this data. The foundation relies on external geographic coordinates from a dedicated provider. Moving up, social features are pulled from platforms like Facebook. Finally, exercise metrics sync with an independent health database. Healthy Lemur itself is just a localized organizational shell. Its primary function is routing information between these separate layers. The app itself doesn't generate any of the core data. Instead, it acts as a highly efficient digital traffic cop. The invisible wires making this routing possible are called APIs, Application Programming Interfaces. Think of an API as strict communication rules. Your app, the client, fires a request to a provider's server. Most mashups use stateless, RESTful architecture. The client asks for a resource, the server validates it, and shoots data back. But that returned data arrives as raw, unformatted text. The developer's main technical hurdle is intercepting that raw response and translating it so it matches the client app's unique visual design. They also have to account for broken links in the chain. If a third-party server crashes or times out, the mashup needs robust error handling to prevent the entire interface from freezing up. By mastering these API calls, developers evolve past writing solitary lines of code. They become conductors, orchestrating vast arrays of external databases to work in harmony. Multiply that single transaction by millions, and you begin to see the true scale of today's digital ecosystem. This chart shows the top mashup tags recorded by ProgrammableWeb. We see exactly which data streams drive the market: mapping, video, and social APIs taking massive shares. Every day, creators mix shopping APIs with real estate and mapping tools, producing entirely new platforms overnight. During the Web 1.0 era, websites operated as isolated, static islands of text and images. They couldn't talk to each other or share features. The shift to Web 2.0 cracked those islands open. The internet became a vast marketplace of modular data blocks waiting to be remixed. Historically, if you wanted to build a global tech platform, you needed massive corporate capital to fund the underlying infrastructure. Mashups bypass that barrier entirely. Today, a small startup designing a revolutionary travel tool doesn't have to launch a geospatial mapping satellite. They just ping Google Maps and get to work on the user experience. In this interconnected economy, hoarding raw data is less important than finding creative, unexpected ways to combine it. This environment makes the world's most sophisticated data streams available to anyone with a computer and an internet connection. The strength of a digital product is now measured by how well it communicates with its surroundings. The most impactful tools synthesize existing knowledge.
Here is our blueprint for today. We'll start with the magic of mashups, move on to designing the interface, and then look at levels of integration. After that, we'll cover evaluating APIs, open up the toolkit of specialized programming tools, and finally, check your understanding. Let's get building. Section 1. The magic of mashups. Okay, before we can actually build anything, we need to know what materials we're working with, right? The crucial thing to understand here is that a mashup isn't just tossing in a basic HTML link to another site. Not at all. It's actively remixing external data and technology services into something completely new. Think of it as taking existing web resources and repurposing them to create a totally unique hybrid service with its own custom graphical interface. So it's really not just borrowing, it's completely transforming. And this perfectly illustrates the kind of diverse content you can use as your building blocks. For instance, you could visually represent location datasets by tapping into the Google Maps API. Or say you're building a social site and want to boost the entertainment value. You can pull in photos, videos, and all that rich metadata straight from YouTube. You can even hook into search data from e-commerce giants like eBay and Amazon. By combining these completely disparate streams of data, we end up creating a much more powerful, permanently accessible tool. It's a total game changer. Section 2, Designing the Interface. Before you start coding your engine and wiring up all those amazing data streams, you really have to design the exterior so users can actually navigate what you've built. When you're the builder, you have to follow these mock-up design steps first. You start by gathering information directly from your users about the features they actually want. Then you consolidate all that data. Next, you collaborate with UX and UI designers to nail down a standard application layout. Oh, and it is absolutely vital to determine the primary viewing device early on. Is it a phone, a tablet, a desktop? Do you need a responsive design? Why do all this up front? Because when stakeholders approve your layout at this stage, the actual mashup can be built with minimal, costly headaches down the line. Now, here's a massive best practice to keep in mind: containable mashups. Notice how the focus here is on building with reusable, containable components rather than one giant monolithic block of code. By splitting the whole application into smaller pieces, containable mashups let you embed a reusable user interface completely seamlessly. It saves a ton of time and keeps your architecture super clean. Section 3, Levels of Integration. So how deeply do these different pieces of software actually connect? Well, according to the source material, there are different depths to this integration. You can stay right at the surface level with a presentation mashup. That's the lowest level, basically using widgets to help users perform basic functions or view virtual content, like maps or images. But if you want to dig deeper, you go for a data mashup. This is the next level up, where you're actually merging distinct datasets, often pulling data from servers in formats like XML or JSON to create something structurally brand new. If you look at the architecture of a corporate mashup server, notice how the process layer right in the middle acts as the grand mediator. It sits securely between the web browser's requests on one side and the external and internal data servers on the other. The protocol adapters and service modules inside that process layer are doing all the heavy lifting, translating data protocols, so these totally different systems can finally speak the same language. And when we look at process-oriented out-of-process mashups, the data flow is actually really elegant. You can see exactly how functionality from external hosts gets pulled in. Data travels over HTTP or FTP straight into the mashup server processes. This involves combining functionality and external processes using languages like Java, PHP, or Python to build entirely new data models inside a server-side process. It's just a beautifully orchestrated flow of data from external hosts right into your centralized app. Section 4, Evaluating and Selecting APIs. An architecture is literally only as good as its connections, right? APIs are the vital machinery that lets your mashup talk to the rest of the web. And just look at that number, 20,000. With over 20,000 web APIs added to the ProgrammableWeb registry in just the last 2 years alone, the API economy has completely exploded. They are the backbone of web development today. But with that kind of massive volume, picking the exact right API for your project is a pretty monumental task. So how on earth do we choose? Well, to solve the problem of data sparsity, developers can actually use the PageRank model. Yeah, the same algorithmic logic that built Google Search. By following a very precise sorting procedure, developers treat edges in a knowledge graph as bidirectional links, set a preference to the node representing the mashup, and then calculate a vector after convergence. Basically, they're figuring out which APIs naturally rise to the top of the pile mathematically. Then you just sort the APIs by their rankings. It's a proven, highly algorithmic way to recommend the absolute best web APIs for your specific build. Section 5, Specialized Programming Tools. All right, now that we've theoretically picked our APIs, let's pop open the toolkit and see what we need to actually write the code. When it comes to the user interface, you have to be able to reliably elicit user inputs and display information back to them. Whether you're rendering a simple HTML page or building a highly interactive AJAX UI, our source points to tools like the Google Web Toolkit, or GWT, and plain old Ruby on Rails as the fundamental technologies for bringing these mashups to life. Let's rapid fire through a few more essential tools you might want on your belt. First up, XML RPC. This is a protocol standard that neatly packages data into opening and closing XML tags. Simple, but totally essential for web services. Then you've got the Google Mashup Editor, which is this fantastic browser-based environment that lets programmers mix HTML, CSS, and JavaScript and compile it all seamlessly. Finally, if you need to embed enterprise applications into other web pages to tailor a specific user experience, the Pega Web Mashup tool is designed specifically to communicate data with host applications without a hitch.
Section 6, check your understanding.
We have covered a lot of ground today, so it's time to test your structural integrity. I challenge you to pause this explainer right now and tackle these research activities. Try defining Web 1.0, listing out the categories of Web 2.0, and most importantly, writing down the core characteristics of a mashup in your own words. Engaging actively with these prompts is honestly the best way to cement this blueprint in your mind. Another great exercise is to spend some time exploring the ProgrammableWeb directory online. One of the best practices from our source material is to look for the newest and most popular APIs before you start creating your own. Try comparing the trending APIs against the newest ones, like the discussion prompt suggests. It gives you a real-world look at those 20,000 plus APIs we talked about and will really sharpen your architectural eye. To wrap up our explainer today, I want to leave you with this final thought. Look at the fragmented internet all around you. There's location data, video metadata, shopping algorithms, and just endless APIs out there waiting to be connected. So what kind of disparate data sources would you mash up to solve a problem in your own life? Grab your digital building blocks and start mashing. Thanks so much for joining me on this explainer, and happy building.
A web mashup is exactly what it sounds like. You take two or more external data sources, and by fusing them together, you create an entirely new, unified user experience. Today, we are going to build a Smart Store Locator. This is a presentation and data-oriented mashup that combines interactive map rendering with real-time climate conditions. To build this, you only need three things: your preferred code editor, a standard web browser to test your work, and active API keys for the mapping and weather services we plan to use. Learning to route and merge independent data streams moves you past writing isolated scripts. By the end of this build, you will be able to construct integrated services that bridge the gap between multiple external platforms. Step 1 is defining our business logic. Our application needs to display physical retail store locations on a map while simultaneously pulling the real-time weather data for those specific geographical areas. This flowchart shows our architectural path. External data flows from API providers, merges at the mashup site, and delivers to the client's browser. At the top are our REST APIs. We evaluate these services first to ensure they reliably return structured data, specifically JSON. This diagram illustrates a JSON payload retrieved using a testing tool like Postman. We make a test call to the Weather API to map out the data structure we get back, isolating the exact key value pairs we need, in this case, temp and description. Pre-validating the API payload structure guarantees our code targets the correct fields later, completely preventing cascading data errors during the actual programming phase. Now we construct the user interface. Good UI design for a project like this relies on the concept of a containable mashup, meaning the application is broken down into smaller, reusable visual components. We establish our underlying HTML and CSS skeleton using a responsive grid layout, ensuring the application easily adapts to desktop, tablet, and mobile viewing devices. This wireframe divides our layout into two independent div containers. We isolate the map in one box and dedicate a separate box for weather data. Rigid CSS boundaries ensure that when dynamic data injects, the visual layout remains perfectly stable and doesn't break. Because of this modular, containable design, if the external weather API completely fails, the weather box simply remains blank. The map container and the rest of the application remain perfectly functional and visually intact. With the UI ready, we move to the core technical task, using JavaScript to create a client-side mashup that fetches and injects our live data. We start by writing an initialization function for our map provider. We use on-demand JavaScript to load the interactive Google Map directly into our first designated UI container. Next, we set up an asynchronous fetch request. This is specifically targeted at our Weather API endpoint, allowing the browser to retrieve data without freezing the web page interface. This schematic maps the critical data handoff. When a user clicks a map marker, our script extracts its exact latitude and longitude, using them to fire a weather request. The API returns a JSON response, which our script parses and injects straight into our UI. Because this data handoff is tied to a click event listener, clicking a completely different map marker instantly generates new coordinates, triggering an immediate update to the weather widget. If you encounter failures during testing, check the developer console. A 401 unauthorized error is a common failure point that indicates your API key is invalid or not being passed correctly in the request header. This seamless hidden data handoff between two separate external APIs creates a powerful illusion. The end user doesn't see two distinct services. They experience a single, unified application. Because our JavaScript runs client-side, API keys remain visible in the source code. Left completely open, this poses a massive liability in mashup infrastructure. We secure the infrastructure by logging into the provider's developer console and restricting our API keys. We configure them to instantly reject any requests that don't originate from our specific, approved domain names. Following organizational requirements, we must finalize the project by documenting the build process. To guarantee future maintainability, your documentation needs to list licensing details, precise APIs used, specific services utilized, and a full record of the configurations applied to your keys. A mashup project is never truly complete when the code simply works. It is complete when it is fully secured, thoroughly documented, and officially signed off by stakeholders. We began this process with separate, raw text files and a couple of isolated data sources. By combining them, we produced a highly interactive, enterprise-ready dashboard. You executed UI validation for containable design, built a live REST API integration using asynchronous data handoffs, and locked down your endpoint security to protect your accounts. To push your skills further, try scaling the project. Pass those same map coordinates to a third external data source, like a local newsfeed API, and inject the results into a brand new UI container. Mastering Web Mashups provides a framework for building applications tailored to specific organizational goals, whether you are streamlining financial reporting or automating live store updates.